Here's another 3 steps to sketch for function transformations. So in this one, we're going to look at the transformation of the cube function, y equals x cubed. So we'll look at the equation y equals 2 times x minus 4 cubed plus 1/2. And to do this, we'll use our table method. So here's a reminder of our equation and method, and then our outline with our table and our grid. So we are transforming our parent function y equals x cubed. And that's our vertical snake. That's what we like to nickname this one. All right, so we can jump in. In our equation, looking at our transformations, this is step 1. We want to see, are there any horizontal or x affecting transformations? So looking in with the x, we see there's 1 in the parentheses of this cube function, and we know we should apply it to our x's as if we were solving. Okay, we think solving order with our horizontal transformations. So if we were to solve this little helper equation that I wrote out, we would add 4 to both sides, and that's what we'll do to apply this transformation to our graph. We'll add 4 to our x's, which will move everything right 4. All right, so that is our first and only horizontal transformation. Now we can catalog our vertical transformations. We know these affect our y coordinates only, and we see there are multiple of them, so we really want to be thinking to apply these in PEMDAS order. So we're looking at this 2 out front and this plus 1/2 in the back. Okay, PEMDAS tells us we should apply multiplication before addition, so we will do this 2 times first. So this transformation, exactly like we see it 2 times, we're multiplying our y's times 2, or we're stretching our function vertically. So we'll record a stretch by 2, or 2 times our y's. Okay, and then secondly, that plus 1/2, we will shift everything up 1/2, or y's plus 1/2. All right, so we have all of our transformations analyzed, and we're ready to move on to step 2. Make our table and apply these transformations. So we know that this, like we said, is the vertical snake function. We know it snakes through the origin. Its parent points are -1, -1, 0, 0, and 1, 1. Okay. And let's just draw a little picture so we know what we're working with here. Okay, it's the one that has the point also 2, 8, or -2, -8. So it's got that vertical snake form. All right, so let's apply our transformations now. We know we have just one x transformation where we're adding 4 to all our x's. So -1 plus 4, 0 plus 4, and 1 plus 4. Okay, so that takes care of our horizontal transformations. And now we can do our 2 vertical transformations. So we know we first stretch by 2, or multiply all the y's times 2. And then from there, so we're using that intermediate column now. We've taken care of the stretch. Now we move up 1/2, or just add 1/2 to those y values. Okay, so we know we'd have -1.5 or -3/2, 1/2, and 2.5 or 5/2. Okay, so that was step 2. Make your table and transform. And we know with this method, our final outer columns are our final points. So we can move to step 3, plot these points and sketch our graph. So we'll plot 3, -3/2, 4, 1/2, and 5, 5/2, or 2.5. Okay, so you can see how this vertical snake has been vertically stretched out a little bit. It's shifted right, and moved up just slightly. So let's sketch our graph through here. And that is a transformation of y equals x cubed using the table method.